Hey everyone, this is lesson 2-3, graphing linear functions. These examples can be found on page 105 to 107 of your algebra textbook if you'd like to follow along. All right, today we're going to talk about linear functions. Functions with a constant rate of change are called linear functions. A linear function can be written in the form f of x equals mx plus b, where x is the independent variable and m and b are constants. The graph of a linear function is a straight line made up of all the sets of points that satisfy y equals f of x. So you might be wondering, when would I ever use this? And actually, in the recent hurricane, Harvey, meteorologists were able to use the linear functions to help them determine the path of the hurricane that it would take until it hit landfall. So we're going to do a problem right now that uses that exact example. It says meteorologists began tracking a hurricane's distance from landfall when it is 350 miles off the coast of Texas and moving steadily inland. The meteorologists are interested in the rate at which the hurricane is approaching land. So the rate can be expressed as change in distance over the change in time. So let's look at the change in distance over the change in time. Let's look at the change of distance first. 350 to 325 is a subtraction of 25. 350 minus 25 is 325. 325 minus 25 is 300. 300 minus 25 is 275, and 275 minus 25 is 250. So our change in distance is constantly minus 25. Our change in time, 0 to 1, is plus 1 hour. 1 to 2, plus 1. 2 plus 1 is 3. And 3 plus 1 is 4. So again, we have a constant change in time of 1. And so what this tells us is that the rate of change is constant and that the hurricane is moving 25 miles closer to land each hour. All right, let's look at a simple example. It says determine whether each data set could represent a linear function. So let's check between the x's. 0 to 2 is plus 2. 2 to 4 is also plus 2, and 4 plus 2 is 6. All right, and looking at the f of x, negative 1 to positive 2 is plus 3. 2 to 5 is plus 3, and 5 plus 3 is 8. So, sorry, I wrote this one down wrong. Plus 3. All right, so what we see is we have a constant change in f of x, which is 3, and a constant change in our x, which is 2. So since they're both constant, it is a linear function. It's linear. Let's look at a different example. Let's look at the x's over here. Negative 1 to 2 is positive 3. Negative 1 plus 3 is 2. 2 plus 3 is 5, and 5 plus 3 is 8. So we may be tempted to say, yes, it's a linear function, but we have to check our f of x first also. So 0 to 1, I wrote negative 0, but it's just 0 to 1 is plus 1. 1 to 3 is plus 2, and 3 to 6 is plus 3. So although it was constant in the x, it is not constant in the f of x. So this is not linear. All right, why don't you give it a try on your own? Put your video on pause for a minute and try it, and then turn it back on when you're ready. Okay, remember, in order to find out if this is a linear function, we need to have a constant change of rate of change. All right, so we're going to have the change of f of x over the change of x. So let's check the change of x. 4 to plus what will get us to 11? 4 plus 7 gets us to 11. 11 plus 7 gets us to 18, and 18 plus 7 gets us to 25. So this one on the top is indeed constant, so we're doing so good so far. So negative 6 plus what is negative 15? Well, it actually is negative 9, or minus 9. Okay, negative 15 plus 24 is minus 9, and negative 24 to negative 33 is also minus 9. So we do have a constant rate of change. The f of x changes by negative 9, and the x changes by 7. So our rate of change is negative 9 over 7, and it is linear. As far as our next one is concerned, let's check it and see. Again, we're going to be looking to see if we have a constant rate of change in the x, f of x, and a constant rate of change in the x. So let's look for the f of x. 7 plus what is 5? Minus 2. 5 plus what gets us to 1? That would be minus 4. And 1 to negative 7 would give us negative 8. So we already can see that this is not a constant rate of change, so this is not linear. Even if we check up here, 10 minus 2 is 8, 8 minus 2 is 6, and 6 minus 2 is 4. Although that is constant, this is not, so it's not a linear. All right, the constant rate of change for a linear function is its slope. And you may remember this from geometry. The slope of a linear function is the change in f of x over the change in x, and sometimes it's called the rise over the run. So one other thing that you could remember, this is our y, this is our x. The rise is the vertical part, so that's going to be the change in y. And the run, that's going to be our horizontal part, that's our x. So it's the slope is going to be y over x, or the rise over the run. The slope of a line is the same between any 2 points on the line, and you can graph lines by using the slope and a point. So let's do one example. The line with a slope 2/3 that passes through point 1, 1. So let's first plot our point 1, 1, and that would be right here. And our slope is 2 over 3. Now remember, slope is rise over run. Our rise is the y, and our run is the x. All right, so it says to rise 2, so we'll go 1, 2, and run 3. 1, 2, 3. So we could put our point there. Rise 2, run 3. Rise 2, run 3. So here we have enough points now. We can just sketch it in. I'm not concerned that it's too accurate, but it should look pretty close. So there is our line. All right, let's try another one. First of all, it says the line with a slope of negative 1, 3. So remember, slope is rise over run. And so we have rise is negative 1 and 3. So our rise, which is the y, is going to change by negative 1, and the run, which is the x, is going to change 3. So let's plot our point to start negative 2, 3, negative 2, 1, 2, 3. Okay, we're going to start there. We're going to rise negative 1, so that actually means go down. Okay, but we're going to run positive 3, so let's go in the positive direction. Make a point. Go down 1 and run 3. 1, 2, 3. Down 1 and run 3. 1, 2, 3. So here's our last point. You can connect your points as close accurately as possible. And there's our line. Okay, why don't you try one on your own real quick. Turn off your video, put it on pause, and then come back. Okay, hoping that you've done that now. So it says graph a line with a slope 4, 3 that passes through 3, 1. So let's first find the plot 3, 1. 3, 1 here. All right, and remember our slope is rise over run. Okay, so it says we're going to rise 4 and run 3. So remember, rise is the y, run is the x. So let's rise 4, 1, 2, 3, 4, and run 3. 1, 2, 3. Rise 4, 1, 2, 3, 4, and run 3. 1, 2, 3. All right, so that gives us 3 points, so that's good enough, and we can just connect our points, and there's our line. All right, recall from geometry that 2 points determine a line. Often, the easiest points to find are the points where a line crosses the axis. The y-intercept is the y-coordinate of a point where the line crosses the y-axis. So this is our y-axis, this is our x. So when you have a line, the place where it intersects the y is called the y-intercept. And the x-intercept is the place where the line crosses the y-axis, or I'm sorry, the x-axis. Okay, so let's do a problem with this. All right, so find the intercepts and then graph the line. So when it says find the x-intercept, you can ask what is x when y equals 0? So let's find out. So we'll say 2x minus 3, and we said that y was going to equal 0 equals 12. So 2x minus 0 equals 12. So we want x to be by itself, so let's divide 2 by both sides. So x equals 6. So we can say when x equals 6, y is 0. And we'll plot that. So 6 comma 0 is right here. All right, so let's find the y-intercept. What is y when x is 0? Well, let's find out. So when x is 0, that's 2 times 0 minus 3y equals 12. So 2 times 0 is 0, so we just have negative 3y equals 12. But we want y to be by itself, so let's divide both sides by negative 3. So y is going to equal negative 4. So when x is 0, y is negative 4. So now we can plot that. X is 0, y is negative 4 down here. And draw our line through, and there's your graph. All right, why don't you give it a try on your own real quick. Put your video on pause till you finish and then come back. Okay, let's solve this one. So this says, let's find the intercepts of 6x minus 2y equals negative 24 and graph the line. So first we're going to find the x-intercept, and in order to find the x-intercept, we say what is x when y is 0? So let's say 6x minus 2 times 0 equals negative 24. So 2 times 0 is 0, so 6x is just equal to negative 24. Again, we want our x to be by itself, so let's divide both sides by 6. So x is going to equal negative 4. So we can plot our point. When x is negative 4, y is 0. So let's go ahead and plot that. X negative 4, y 0 is right there. So you can see that's going to be our x-intercept. And now we have to find the y-intercept. What is y when x is 0? So let's see. 6 times 0 is minus 2y, because we want to find out what y is, equals negative 24. So 6 times 0 is 0, so that just leaves us with 2y equals negative 24. We want y to be by itself, so let's divide both sides by negative 2. So y is going to equal 12. So when x is 0, y is positive 12. I'm sorry, I said negative. Okay, so we can plot that 0, 12 is way up here, and then we can just draw our point in, our line, and there it is. All right, let's move on. All right, linear functions can also be expressed as linear equation in the form y equals mx plus b. And you probably are familiar with that. When a linear function is written in the form y equals mx plus b, the function is said to be in slope-intercept form because m is the slope of the graph and b is the y-intercept. Notice that slope-intercept form is the equation solved for y, so it's y equals something. All right, so let's do a sample here. It says write each function in the slope-intercept form, then graph the function. So in order to get it in slope-intercept form, we first want to solve for y. So here our problem is 3x plus y equals 5. And we want our answer to be y equals something, but right now 3x is added to it. So let's subtract 3x from both sides. and 3x minus 3x is 0, so that leaves us with just y equals negative 3x plus 5. So now we can see that we're in our slope-intercept form. And so let's find the y-intercept. And remember, to find the y-intercept, we say when x is 0, what is y? So y equals negative 3 times 0 plus 5. So when x is 0, y, negative 3 plus 0 is 0, so it's just 5, equals 5. So we can plot our y-intercept, which is y equals 5, 0, 5, which is right here. All right, now remember, slope is going to be our m. All right, they told us that our m is slope, and slope is the same as rise over run. And ours says that it's negative 3, but what do we put for that 1? Well, there's always an understood 1 down here. So our rise is going to be negative 3, and our run is going to be 1. And remember, this is y over x. All right, so let's see. We already have 1 point here. It says rise negative 3. Well, negative goes down 1, 2, 3, and run positive is over here. All right. And again, rise negative 3 and run 1. And one more time, rise negative 3 and run 1. We think of rising as going up, but it's actually, it could be up or down. So then we plot our points or draw our line, and there you have it. All right, here's another one. Graph the function in slope-intercept form and write each function in slope-intercept form and then graph the function. All right, so first of all, again, we want to solve for y first. Now this one looks a little trickier. 3 over 2y equals x minus 3. So what are we going to do about this problem? Well, y is not by itself. It's multiplied by 3 over 2. So we want that to be actually 1. And so what we could multiply both sides by is 2 over 3. Okay, so we're going to multiply both sides by 2 over 3. And when we multiply, we see that 2 times 3 is 6, and 3 times 2 is 6. So this whole thing is just 1, and 1 times y is y. So I'm going to go ahead and put my 2/3 here first, just so you can see it a little better. And then we're going to actually distribute. Okay, so let's distribute our 2/3 to the x. So we have y equals 2/3 x minus 2/3 times a negative 3 over 1. And I always get confused, so I'm going to say that's plus the opposite. So when we multiply it through, we have y equals 2/3 x, and a negative times a negative is a positive, so plus 6 over 3, and that reduces, 3 goes into 6 to 2. So our y-intercept form is y equals 2/3 x plus 2. All right, so in order to plot this, we always figure out what our y-intercept is, and we know that it's actually going to be this 2, but let's just prove it out. So we ask the question, what is y when x is 0? So 2/3 times 0 is 0, so y is equal to 2. So our first point is going to be 0, 2, and it'll be right there. All right, now we're going to look at our slope, and our slope is this m, and our y equals mx plus b. So our slope, I'm going to write it up here, is equal to 2 over 3, and that's rise over run. So we're going to rise 2 and run 3. So rise 2, 1, 2, and run 3, 1, 2, 3. Rise 2 and run 3, 2, 3. And rise 2 and run 3. And there we have it. So let's just go ahead and draw our line in. And we did it. All right. So that's a little more complicated, but I think you got it. Okay, so go ahead and try this one on your own. Push pause on your video, and then when you're finished, come back on and we'll show you how to do it. Okay, so the problem says to write each equation in slope-intercept form. So let's go ahead and write each equation in slope-intercept form. We're going to start out 2x minus y equals 9. And we can see that y is not by itself. There's a 2x added to it. So let's subtract 2x from both sides, minus 2x. All right, so that leaves us with negative y equals negative 2x plus 9. All right, now we still have this understood 1 here, and we don't want anything with our y. We want it to be positive, so let's divide both sides by a, or we could actually just multiply both sides by a negative 1. Okay, so that's going to leave us with y equals. So let's just take our negative 1, and we can actually bring it up here, negative 2x plus 9, and we need to distribute this negative 1 to both of these. So negative 1 times negative 2 is positive 2x, and negative 1 plus 9 times 9 is a negative 9. So we have y equals 2x minus 9. Now to find our y-intercept, we just say what is y when x is 0? So 2 times 0 is 0, so y will equal negative 9. So our first point is 0, comma, negative 9. So over 0 down to 9. All right, now our slope is this number right in front of our x. Y equals mx plus b. It's our m. So our slope is equal to 2. But slope is rise over run. So what is 2 over? An understood 1. So we're going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And that's enough for us. So we just connect our dots, and there's our line. Okay. Here's another on your own one to try. Again, try it on your own and then come back and turn your video on. All right, so this one's written a little bit different, so we're going to have to get our y on one side and everything else on the other. So let's just write the problem out again. Equals 15y plus 30. All right, well, there's a lot of different ways we could do this, and I like to keep my y positive. I don't like to have to multiply by that negative number. So I see that 30 is connected to my 15y with addition. So I'm going to go ahead and subtract out that, and I'm going to say 5 and put in minus 30 on this side. So that leaves us with 5x minus 30 equals 15y. Now I want y to be out by itself, so I'm going to have to divide both sides by 15. All right? So here's what we have. So 15 over 15 is y. But notice that this has got a common denominator. So it's actually 5x over 15 minus 30 over 15. So now we can reduce. 5 goes into 5 one time. 5 goes into 15 3 times. So we have x, and then here 5 goes into, or 15 goes into 30. 15 goes into 15 one time. 15 goes into 30 two times. So we actually have x minus 2 equals y. And I like to rewrite it into the y equals mx plus b form, x minus 2. So our first point is going to be the y-intercept. So what is y when x is 0? Well, if x is 0 minus 2, then y equals negative 2. So our first point is 0, comma, negative 2. 0, negative 2. Now, y equals 1x minus 2, so that means our slope is equal to 1, and that's actually an understood 1 over 1. So it's going to be rise 1, run 1. So rise 1, run 1. Rise 1, run 1, and rise 1, run 1. So now we have enough points there. We can connect them. That was terrible, but you get the main idea. All right, so that's on your own. All right, One last example thing that I want to talk to you about is what about if we have a problem that says x equals -3? And we talked about this one at the beginning of the year. And what that means is no matter what your y is, x is always -3. So let's go to -3. Our x is always -3. So if y is 1, x is 3, x is -3, y can be 1, y can be 2, y can be 3, whatever. Okay, but no matter what, x always has to be -3. So when you see x is equal to -3, you actually have a vertical line. And the same thing is true for y. It says y is 1. So no matter what your x is, y is always 1. So x could be -1, x could be -2, x could be 8. It doesn't matter as long as y is always +1 in this case. So it seems kind of like it's flipped a little bit. If it's x, you're going to have a vertical line, and if it's y, you're going to have a horizontal line. But just think x always has to be whatever, and then y always has to be, in this case, 1. So that is it for your lesson. Why don't you try one more on your own? You can turn your video off. All right, you're back. So this one says x is 0.5. So no matter what the y is, we're always going to be at 0.5. So our line is going to be, this is going to be x equals 1/2 or 0.5. And then the y is equal to -5. So it means no matter what x is, y is always going to be -5. So this line is y equals -5, and this line right here is x equals 0.5. All right, I hope that you have learned something that you didn't know. Most of this was probably a good review for you. So I will see you in class the next time. Have a great day.